many different ways we could apply sinusoid graphs. One would be, we used to do one with tides where we go to different beaches throughout the world. Problem with that one was some of those shapes weren't nice and sinusoidal like that. So we've kind of given up on that one. We're trying something a little different this year. This is going to be the length of day sinusoid graphs, and it's got a couple of neat things to it that I think you're going to like. You're asked to find and analyze real-world data from the internet regarding, you know what the internet is, right? I don't know why I wrote from the internet, but regarding days and number of hours of daylight anywhere in the world, and then construct 4 to 6 functions to predict future daylight hours. So this is going to kind of be in 2 parts. The first part is you're going to construct one equation. And that equation, of course, is your y equal to d plus a cosine b t minus c. You remember that, right? You remember that one? And remember how we found d? D was the what? Well, let's go back. So the way you're going to do that is you're going to pick 2 data points. One's a high and one's a low. This will be, T1, this will be T2, this will be the low, this will be the high, and it'll be half of a cycle. If you continued it, would make a complete cycle, right? So do you remember, how did we find the d value? We took the high and the low, and what did we do? We added them up and divided by 2. Very good. So that's how we found d. The a value, we took the high, and then what did we do with the d value? Right in the middle here is your d. What do you do to find the amplitude? Yeah, just subtract them. That'll get you your amplitude. This is your amplitude. This is your amplitude. Both of those are your amplitude, all 3 of them. Okay, then for b, you took 2 pi and divided by the period, right? And the period, here's half of a cycle. So if this is half, you're going to have to double it to get the entire period. Okay? And then the last thing you do is to find c, and c is the x value of the peak. So that would be T1, wouldn't it be? In this case, it would be T1. And you just put that into your formula, and you got it. So the first part of this lab, see if I can put all this together, is to construct an equation. And so with that, what I'm going to ask you to do is to list data and make equation. Then I want you to plot on calculator or Desmos, and then enter curve, sinusoid, and see how it fits. So you're going to list the data, you're going to make an equation, you're going to plot on the calculator, and then you're going to enter that. And you're going to do this, all of this, for one equation. I want a screenshot of that actual curve going through those points. Okay? And how many points do we need? How many points did we need for this? A high and a low. You only need 2. If you want to put in more, that would make it more impressive. And but that's all you need. Then for the second part, what I want you to do is I want you to make 3 to 5 more equations. No graphs needed. Okay? So the first one, you're going to graph it and plot it, take a picture of it, or a screenshot or whatever you're going to do, put it into your lab write-up. You're going to do this for one. But the other ones, what you're going to do is you're going to list town. And I would probably put latitude and longitude in for that. And then you're going to find equation. Hope this is making sense. And then the third part, so you've done a total of 4 to 6 of these. Then I want you to write 3 conclusions regarding cities or towns, locations, and y equal d plus a cosine b t minus c. So things that you might look at is if 2 towns are in the same, well, hold your arms up with longitudes. What do longitude lines look like? Show me with your arms. What do longitude lines? Yep, show me vertical. How about latitude lines? Horizontal, right? So let's say 2 cities are about at the same latitude, okay? What's happening with A, D, B, and C? If they're in the same longitude, what's happening with A, B, C, and D? Okay, that's going to be in your conclusion. And that's it. That's it for this lab. We'll do a full lab write-up on this. It's going to be due a week from Friday. So not this Friday. And we'll do a little bit this week, a little bit next week in each class period. You'll probably get most of it done in class. But it's not due this Friday. So let's go back. And this has got probably more information than what you need, but the primary thing you're going to do is the 4 to 6 equations, and you're going to compare latitude, longitude of these towns and see what's happening to A, B, C, D. In that conclusion, if you're a little confused with the conclusion, I also have these follow-up questions that might help guide you a little bit if you want to do that. But feel free to come up with your own questions. Okay, so first thing we're going to do is you're going to go to this one here, www.timeanddate.com/sun, and I have the sunrise sunset calendar. Let's put in, let's see, what would that be? What is Minnetonka? 55345? Is that right? Yep. Says Minnetonka. So if you go to this website, and you can find other ones too, but I like this one. Uh-oh. There we go. Okay, and if you look at this, you can see we put in the town, and then if you scroll down just a little bit, you see this weird band, and this band controls the day, and I have to control it on the computer here, and this will tell me what day. So if you look at the pink there, you see January 1st, 2nd, 3rd, 4th, 5th, 6th, and so on. What's happening to go down to daylight hours. What's happening to the daylight hours as I move from January up to March? What happens to the daylight hours? Increasing. Do you see that? Right down here, 11:25 is the daylight hours. What's this weird break here? That looks bizarre. What's that? Yeah, daylight savings time. Everything is just shifted vertically. There's your D, right? Changing. Okay, and then you go along here. There's going to be a high point. The high point is going to be, looks like, somewhere around June 21st, 22nd. What's that? June 21st, 22nd. Summer solstice. So that's your greatest time. So what I want you to do is I want you to come up with an equation. This would be your high, and then to find the low, you're going to slide this down. And you can go either way. It looks like the low is probably going to be down in here. Is it 47? Yeah. Looks like that's around December 21st. Sure. That looks like the low. And then you've got the number of hours. And then you can construct it. Now, when you look at number of hours, is the time going to be affected by daylight savings time, the total number of hours? No. So don't worry about daylight savings time. That's off the chart. But what you might be wondering is, on December 20th or 21st, what day of the year is that? How many, from January 1st, what day is that? Or going back to June 21st. June 21st. What day is that? We need a coordinate. We can't say the x value is June 21st. That doesn't make any sense. So we need a number from 0 being January 1st. So if you would, zip on down to you look at day of the year calendar. So if you go to the next slide, you can see finding the day number, day of the year calendar. You just click on that, and then let's say we want to go June 21st. June 21st, 2019, and then don't hit start, hit calculate day of year. There it is, 172. Let's go to October 31st, Halloween. Okay, how many days is that? Calculate day of year, 304. So what I want you to do is I want you to generate, pick any city in the world that you want to look at. And then what I want you to do is take any city in the world, and I want you to see if you can build that equation. We're going to do that in the next few minutes. See if you can build the equation, maybe even graph it if you can. But just want to go back here. So you're going to find a city. You'll enter that city, and you can put in, I like to just put in cities like Paris, France. You write in Paris, it'll do this for you. Paris, France. Maybe you want to have Athens, Greece. Athens. Yep, that'll work. Oop, didn't like that. So what I did, Athens, then I need to click on the entry in blue, and then you've got that. Then generate length of day, the day, and then the length of day as two coordinates, like I have over here. Get the high and the low and make that equation. Take a look at the clock. We're going to do this for 10 minutes, and then the lab is going to be a straight lab write-up. And for those on the computer that I'm recording this for, you're going to have the purpose, procedure, how you collected the data, calculation of the 6 equations, and your conclusions. And your conclusions will be 3 conclusions about what you found out about 6 different cities of similar latitudes and longitudes. All right, so make the equation first and then get your data.